So I'm sure some of you have come up with the idea that, we have linear regression. And linear regression regresses real valued outputs. Well, 1 and -1 are also real valued outputs, right? So why couldn't we use linear regression for that? In fact, we can, right? Any type of a binary valued classification task, we can also map to a regression task, right? It's just that we're looking to make the values of the outputs close to 1 or close to -1 in this case. We don't have to use something like logistic regression, which is trying to compute the probability of the positive class against the negative class. So is this really a good idea? So that should be fine, right? If everything we end up is +1, then certainly it's on the positive side of the sign function, so that's going to be okay. And if it's a negative example, it's going to be below 0, so that's fine. It's going to be -1. So we can say, in short, it's going to be likely to agree with this. So are they really good weights for classification? What do you think? So it turns out they're actually good initial weights for classification. Why is that? Well, when we did both perceptron learning as well as logistic regression, we started out for convenience, by convenience, with a weight vector of 0, right? But we didn't have to initialize it that way. In fact, we could have initialized it to any other vector. And so we could take the Q to use this linear regression closed form solution that might be easily computed because you only do one step. You only do a one-step solution, as we saw on the last page. We only do a one-step solution, as we saw in the last section, to find the optimal weights theta, because we're just taking an analytic form for the solution. But why wouldn't that be good overall? It's helpful to look at this picture here. So I want you to think about what linear regression is actually trying to do with all of the negative classes. Let's say these are negatives over here, okay, and all the positive classes over here. So the blue circles are positive, the red crosses are negative. Take a minute and think about this. Right, so each of these, this entire mess of negative values, are all supposed to have the value -1. And all of these positive class examples are all supposed to have the point +1. Well, look at this hyperplane. If we are setting this particular distance, let's say here, to +1, that means this distance over here is -1. And you know what happens then, right? All of the other examples, all in this range, are at -2, -3, -4, -5, etc. And that means they have an incredible amount of penalty because this distance is being squared. All of these red axes should ideally land somewhere along this line, right? So the end result is that this particular hyperplane that I'm showing you, although it doesn't look so bad from a classification point of view, looks really bad from a regression point of view because of all of the neighborhood of points down here. So what's going to happen? Because we're trying to make all of the minuses, all of the negative examples equal to -1, it's going to move the boundary this way, right? So we might end up actually getting an optimal hyperplane somewhere around here, right? Because all of these examples over here, they're all supposed to be -1s. They hopefully aren't too far from the center of mass, okay? That might be where -1 is. And all of the ones over here are +1. Right? And you can see this particular hyperplane that I'm drawing here is pretty terrible for classification. It's getting all of these things wrong, and there's a much better hyperplane. right? This line over here looks a lot better than that, okay? Because we're getting most of the signs correctly implemented for that. So we have positive examples on this side, negative examples over here, okay? So that's why there's something wrong, and this is why we can use linear regression to set initial weights. We're going to start by looking at this black plane. This black plane as an initial starting point, and then with the linear regression algorithm, either with the logistic regression or perceptron algorithm, we're going to finally move it to the proper place up here.